Sixth graders, welcome back to the next set of notes here. Up here on your screen, you'll see where we left off last time, continental and oceanic plate boundaries, which is a type of convergent boundary. We're going to go through the other two types of convergent boundaries today, and so I'm going to keep referencing back to this type of boundary as well, the continental oceanic. And the big thing to remember with these three types of convergent boundaries is all about this process of subduction. So when you know that there's subduction, then you will know some of the geologic activity. Okay, and we'll come back and we'll talk about that when we get to oceanic plate boundaries here with the second slide. But let's start with continental plate boundaries. So take a look at the picture here. And the big thing that you should notice is that while it looks like there is some of the lithosphere being pulled back under, notice that it's the continental crust that we're going to be paying attention to. And while, yes, some of it might get pulled down a little bit, it doesn't get pulled all the way back down into the mantle to be recycled, like we talked about before with subduction. So the big thing with continental to continental plate boundaries is that there's no subduction going on because both plates have the same density. Okay, they're continental crust. The crust is the same density rock. So if they're the same density, neither of them get pulled underneath. And the result is that actually both plates get pushed upward. Okay? And that forms mountains. So when we get big mountains, like even out in the west, the Rocky Mountains for us, and we can talk about that some other time of how they formed out there. But you have the Rocky Mountains. Someone's calling. They'll have to wait. I don't know if you guys can hear that, my phone ringing in the background. But the bigger ones, like the Alps and the Himalayas, all cause because it's two continental plates that are coming in contact with each other at a convergent boundary. The other thing, of course, is earthquakes. And usually at continental to continental convergent boundaries is where we get some of the more frequent earthquakes. But as you're seeing as we go through the notes, it's pretty much every boundary. Wherever you have plates touching and moving, you have a chance for some earthquakes. Again, the big thing is that there's no subduction. So not only is there no subduction, but that means there's no volcanoes, because subduction is going to cause volcanoes. We'll get back to that here in the next slide. Some of the examples, like I mentioned, the Himalayas and the Alps. Those two places, really well known for some of the most breathtaking and largest mountains that we have. So here's a picture. India during Continental Drift and the breakup of Pangaea, this subcontinent of India literally crashed into the Eurasian plate here, forming the Himalaya Mountains. Excuse me. So that's continental to continental. Mountains, earthquakes, no subduction. All right, oceanic to oceanic. This diagram should look kind of similar to oceanic and continental. We're seeing one of the plates get pulled under. And that might be a little bit confusing because you might be saying, well, wait a minute, continental to continental were the same age, and so the densities were the same, so there was no subduction. Well, what's the difference here? Well, you have to go back and remember seafloor spreading. Not all of the ocean crust is the same age. So the older oceanic plates, the older ocean crust, is actually more dense. And so because of that, when it comes in contact with younger oceanic crust, the older plate gets subducted. When we have subduction, it's some of the same geologic activity, just like we saw with oceanic to continental. So it's almost easier when I'm trying to remember, well, what's happening at these boundaries? I first ask myself, is there subduction? If there's subduction, that means there must be at least one ocean plate, right? Oceanic to oceanic, there's one ocean plate. Actually, there's two of them. One of them is subducted. Continental to oceanic. One of the plates is oceanic, so there's going to be subduction. And so that's the first question I ask myself, is there going to be subduction? If there's going to be subduction, then I know the following things are going to happen. One, there's going to be ocean trenches. So here's the ocean trench for oceanic to oceanic. It's kind of away from land, a lot more away from land, even though you have these islands here, but away from continental plates. So you always have ocean trenches when you have subduction, and you're always going to have volcanoes. Okay, so now it just matters, where are you going to have the volcanoes? Well, if it's oceanic to oceanic, then obviously they're going to be out here in the ocean, right, out in the water, and so you're going to get these actual volcanic islands that are forming. If it's oceanic to continental, then you're going to see usually volcanic mountains on the land. Okay. But subduction means volcanoes, means ocean trenches. Of course, again, you're at a convergent boundary, so there's plates crashing into each other, so earthquakes are also there. So where are oceanic to oceanic plate boundaries? Philippine Islands, the Aleutian Islands, Japan, Southwest Pacific Islands. As you guys are going through, and by now, this is now Thursday, you guys should be pretty far along on your map activity, and so these are some of the locations that you should have seen oceanic to oceanic plates in that type of convergent boundary collide. All right, so if you need to pause, go ahead and hit pause, but this is, again, the important summary. And notice that this chart's way bigger than the divergent boundary. There's a lot going on. It's not hard to understand. The content isn't something where it's difficult, where it's like, oh my gosh, I don't get this. I don't understand what's happening. It's not that. But there is a lot of information. And so I've been out all week. You guys have been doing notes, and you've been doing this plate boundary activity. I haven't given any homework. I would highly suggest to you tonight or over the weekend that you just spend some time going back over these notes and studying these charts a little bit so that you remember exactly what's the boundary type, what's happening, what land formations are there, and then it's good to know some examples. Okay? So, continental to oceanic, you have one of the plates being oceanic, so that means subduction, right? Ocean plate is more dense, so it goes under. If there's subduction, you get ocean trenches, you get volcanoes, and always earthquakes. So you can see earthquakes in all three. If it has oceanic as one of the plates, then you see subduction. And if you see subduction, you see trenches, ocean trenches, you see volcanoes. If it's oceanic, it's volcanic islands because they're out in the water. If it's continental and oceanic, then they're volcano mountain ranges that are going to be on the land. Okay, and again, here are some of your examples. All right, so if you need to pause it, go ahead and hit pause so that you get this. This is a really important screen. And like I said, I think you should go back and study tonight or tomorrow, over the weekend. Just read through these, look at your charts, because this is important information, and I'm expecting you guys to know this stuff when I come back. Okay, this isn't just something that you were just doing while I was gone. You need to know this stuff. I don't want to have to then spend a whole nother week going back and teaching this stuff again. You guys need to know this. So if you need to spend some time outside of class, I have not given any homework. Spend some time to get it done. All right. One more video tomorrow. We're going to go through the Ring of Fire, which hopefully you guys pay attention to on your plate map activities. And then we'll really quickly go through the last of the boundaries, which is transform. All right, keep working on your documents, your plate boundary map activities. As groups are getting closer to finish, I will post another video with some of the activities that you can be doing if your group is done. Thanks. Have a good day.